I'm here with Abhishek from Advanced Energy, who's going to show us,
Electrostatic check controller.
tell us about who will benefit from this product, how it's different from anything in the industry right now, and we can get our conversation started that way.
All right. So I'll just go over the basics of the product. So the electrostatic check controller is basically the main function of it is to make sure that the wafer is clamped or chucked, or in simple terms, sticking to the pedestal. Um, when when we have this, you can see now it's going up and down. So in any processing system, a wafer comes in, it sits on a pedestal or a chuck, and then before the process starts, meaning when we change the pressure, we start to flow reactive gases, um, we have to clamp the wafer or chuck the wafer. This is done because we don't want the wafer to fly out of the system. Once that is done, which is what the function of the controller is, to chuck the wafer, then we do the process, which is can be deposition, etch, implantation, any of those. We then dechuck and get the wafer out. That's a very run-of-the-mill standard process flow for any different types of systems in the semi industry. What's unique in here is normally this happens in a closed system. There's no way to tell whether the wafer is clamped, not clamped. But what we offer here is the ability to sense whether when the wafer clamps, when the wafer declamps, and then when it's ready for process. That we use a capacitive sense, which basically is a differential in the voltage that helps us tell when the wafer is clamped and declamped. And that is a very unique thing in the market, which only Advanced Energy offers with their electrostatic check controllers. These typically come in monopolar, bipolar, hexapolar versions, which um, gives you more control in terms of how you're checking. So specifically in complex systems like ion implant, you have to get the wafer up vertical. Normally the wafers are horizontal. In ion implants, you have to get the wafer vertical. So you have to make sure that the chucking is really good and the wafer doesn't fall off. So that's where we can demonstrate that we can do that reliably, repeatably over time.
What things does this address for directors of engineering, directors of product managers who are kept up at night with challenges that just plague them? Where does this come in?
So one of the basic tenets in the semi industry is how well you can control the process and how fast you can do. So throughput. In this scenario, we can exactly tell when the wafer is clamped, so they know exactly when to start the process, they know exactly when to finish the process and declamp, and then at the same time they're not worried whether am I starting my process flow too fast or too slow. That way they are safeguarding the wafer, so that gives a unique ability for them to control each and every aspect of the process flow. So this is in a way can improve throughput, can improve the process timing, and also the control, the ability to control. So those are kind of the basic um, tools that they get to play with.
Okay. Well, thank you so much for your time. I appreciate it.
Thank you so much.